Okay, good morning. Thank you very much for the invitation, Ulysses. It's good to see a lot of old friends here, especially Salvatore. He was at CNP in 2019, and I think from there, from then on, we have only increased our, let's say, collaboration. So I'll talk a little bit about CNP and how CNP got involved. Is the big black one, no? Ah, okay. So this is CNP. CNP has many more activities besides what we're talking here, talking about. So we have biosciences, biorenewables. We have a nanotechnology lab. We have the traditional synchrotron light source. I'll talk a bit more about it. And we have, that's why I highlighted over there, the engineering instrumentation lab, which is mostly connected to the discussion here. CNP is connected to, and we have a faculty also, ILUM. We have started a few years ago. We are connected to the Ministry of Science and Technology and Innovation, just like CBPF, but in a different management model. They are directly connected to the government, and we are a private nonprofit organization that signs a contract with the Ministry of Science and Technology to do everything we do here. So what is called in Brazil Organização Social. So all our employees are CLT, so it's the private way of hiring people here in Brazil. We have close to 1,250 employees, and if you count students, trainees, and outsourced personnel, we are close to 2,000 people. So it's a big increase from the time when I got there in 2009. I think we're close to 300 people. So, and it's interesting because everything started here at CBPF. I was talking to Marcio. So the first discussions about building a synchrotron in Brazil, the discussions were done here. Roberto Lobo was the director. He was visiting us 1 week ago, and we're talking about this very early days. But then eventually it went to Campinas, and I think it was a very important turning point in the Brazilian science because, of course, big facilities or big science was mentioned this morning when you talked about CERN. You can't talk about the same size, but in a sense, you can say it's a big science project. So it was a very pioneering lab. An important thing is that instead of buying an accelerator, the whole idea was to learn how to develop. It's something that CBPF also always tries to do with all the research and development done here. So important people here that were involved, Silon, Ricardo Rodrigues, and Aldo Krajewicz. I think Aldo even spent some time here. Unfortunately, Ricardo and Aldo passed away recently, but Silon was also visiting us last week. So training human resources was fundamental and learning how to actually do instrumentation. So the whole idea is to learn how to do the project, but not only the project and buying from abroad. So the idea was to do the project and learn how to produce. Back then, you didn't really have the chance to involve or engage Brazilian companies. Those were very difficult times for those who have lived inflation of, I don't even know how many percent a month. So it was very difficult to actually do any and sign any contract with companies. So the whole idea was to actually produce internally. This was important also to learn how to produce. This is the old accelerator. And then it operated for many decades. But it was not a competitive machine. It was very important to learn. It was very important to actually develop a community of users and to acquire the knowledge to how to develop, but it was not a competitive machine. And then the idea was to build a new light source. Initially, it was going to be a third generation light source, similar to most of the good accelerators all over the world. But eventually, I would say a bold, maybe crazy move that today was, in hindsight, very important, was to move to a new technology that was not yet working in the world, that was called so-called fourth generation light source. So we had to develop and invent many of the, let's say, solutions. This is the real accelerator over there. So we just passed through the LINAC, goes all the way to 150 million electron volts. And then you go to the booster, it ramps up to 3 GeV, and then transfers to the storage ring. Is a half a kilometer, roughly half a kilometer storage ring. and we divide it in 20 centers. Then you deviate the trajectory of the electrons to generate the light, the synchrotron light. You collect them on the tangent, on the so-called beam lines, and then you go out of the concrete tunnel to where the experiments, the usage of the synchrotron is actually done. So the accelerator is the source of let's say, of the science done over there. So it's not so you don't use directly as a collider the accelerator. So, and we had to develop a lot of technology. Some of them are patented, and especially I'll talk more about magnets, but it goes to all the way to X-ray detectors, monochromators that are unique in the world. And these delta undulators also you can't install in any place, and we have it installed on Sirius. And this was the first agreement since I was over there. CERN has been important in this history. I won't have time to talk about it. But because we needed to use this NEG coating, it was a proprietary technology of CERN, so I had to sign an agreement, and CERN let us use. That's why you had to also produce all the vacuum chambers in-house. But we did this, and today we have a strong group in vacuum chambers. Then it was strategic to actually connect to the Brazilian companies. It was discussed this morning, for example, that Portugal made the effort. It was clear to us that we had to make this effort for two reasons. First, it would be very difficult to produce everything in-house. For example, now we were talking about 1,000 magnets. It would be complicated to actually produce it in-house. But we didn't want to import. We wanted to engage Brazilian companies because strategically this would be fundamental for the survival and continuation of the project. And we have been successful. I won't have time also to actually talk about all the strategies, but more than 80% of all the money we spent were spent in Brazil. It was a huge nationalization. I think probably one of the biggest in such kind of projects in the world. We have dozens of companies from small startups in the case of detectors, all the way to big companies like WEG. So I'll focus on magnets because this is important for the future, I would say, especially the future connected to CERN. As I said, we developed the technology. We built the magnets in-house for the first synchrotron, but for Sirius, the large number required that somehow we would find a partner. And of course, you don't have any company that produces magnets, accelerator magnets. But a magnet is not so different from an electromotor. That's what WEG does and does competitively worldwide. So I think today is the #1 seller of electromotors in the world. So it took us a lot of, let's say, energy to actually engage WEG. Today, we're strong partners in many different areas. We had about 1,000 electromagnets divided into dipoles, quadrupoles, etc. And the success case was to engage WEG in this project. They initially thought it would be very simple because 1,000 for them is ridiculous in terms of number. So they thought maybe in half a year they would finish everything. It took more than 4 years because they had to learn to actually produce things with the requirements, technical requirements. Was an extremely interesting experience. So we had to develop a special way of interacting with them. So the design was ours because they were not going to hire people to actually learn to design magnets for accelerators. And we had a partnership where prototype and pilot bench, if successful, would lead to us signing a contract for serial batch and then eventually validation. It was extremely successful. They was the very first project in the whole history of WEG where they actually built climate, let's say, stabilized assembly line for the magnets. But not only the magnets is the biggest story, I would say. But for example, if you look at the girder, let's say the concrete supports, the resin that attaches this to the ground, all of this required a lot of interaction and innovation with different kinds of companies, and we're successful in that, and would be, for example, ready to have this fabricated to other projects, because now we have the companies here in Brazil. So CERN cooperation and opportunities. it's important to highlight CNPEM is not a high energy physics. This is a high energy physics meeting. CNPEM interacts with the community through the competence it developed throughout the decades in accelerator technology and innovation. But you don't have high energy physicists, and we are not planning to have an accelerator engine, let's say, high energy physicists. And we interact with neutrino people as well. We have, we're going to fabricate some of the detectors for Ettore over there, but we are not interested in neutrino physics. So that's important for possible cooperations in the future, understanding the role that CNPEM might have within the community. But we have many similar things to CERN, especially if you look at an accelerator, special accelerator, not only, but special accelerators, you have a lot of components that are similar to the components that we need to actually learn and build to actually make our accelerator work. So this actually made total sense for us to get closer. And we decided to sign an agreement in 2020. I'm better in this picture, so I'm not hiding behind the agreement itself. But it was, for example, very important to us to acquire superconducting technology. I told Salvatore we knew how to build some of the best magnets, electromagnets in the world, but we didn't know how to actually build any superconducting device. And so we signed an agreement from our side. That was an important thing to actually start developing this device. I was glad to hear Salvatore saying, South of Texas, this is the first device he knows that will be installed. Next year is going to be installed in Sirius. It will provide the first beam line of close to 7 Tesla, which is only possible because we have a superconducting magnet. And we also wanted to move towards proton accelerators. We want to learn this technology and initially connect it to health, but learn how to actually build a proton accelerator. And it was very important in the beginning, the interaction for this RFQ. As far as I know, it's the first full cavity that was built also here, and that works. And we have accelerated protons close to 1 MeV. Now we're going to actually continue this to higher energies. And then it was, let's say, logical that CNPEM would participate in a more, let's say, deeper way once Brazil became an associate member state. So the Ministry of Science and Technology asked us to actually help ILO, Rafael Navarro, who is here. Hello, Rafa. So he is actually, if you see, he signs organization CNPEM because that's how we're implementing his activities. So we're already supporting. And an important thing to understand when we get involved with this is that we help to de-risk the involvement of Brazilian companies. As I said, the vast majority of the companies here in Brazil won't have dedicated people that know about accelerators. So they won't even have people to actually sit down with the guys from CERN to discuss technical issues. So it's essential that CNPEM helps sort of a midfield connecting both sides. So we understand this role. We are very happy to actually have this kind of participation, and we fully support all the research work that Rafael does. So it was already mentioned, FCC is the very largest next big project, but you have high Lumi and you have, let's say, also improvements to doing some of the detectors. And because we have made the interaction, let's say, agreement with CERN, we have developed successfully some projects. We have the history of magnets. We have interaction with Brazilian companies. So people started to come to discuss the possibility of engaging CNPEM on, I would say, more challenging and more projects that would be, let's say, bring more visibility to actually the development here. One of them is the discussion we've been doing with the people from ALICE. We have people here participating on the discussion as well. The whole idea is to build the superconducting detector magnet. For example, this is an important also distinction. Some of the community the scientific community, they discuss how they could participate. For example, CNPEM would never be able to say the specifications of this magnet, because this requires high-energy physicists. You have to decide the science, and you have to decide the specifications. But we know how to, once you give the specifications, we know how to make the project of a magnet. It's an engineering problem. So I always say, don't try to do the engineering problem that we already know how to do. Do the science problem that we're never going to do. So each one will do what they do best. Sometimes they are not so happy, but I think that's the smart way to actually move on without duplicating all the efforts. So the whole idea is try to engage also Brazilian companies. There is a big challenge because let's say they have many possibilities, but the one that they would like the most is to use these Rutherford cables. That will be today, as far as I know, in the world, you can't buy them. So we have to actually bring back some companies that could have this capability. And we have already partners that said they could actually produce this. And we might even engage WEG again, depending on how this moves. So there are still challenges for the, let's say, financial, how to actually pay for everything. But we think we're actually going to have a successful case here. And now we're very excited about the agreement we're going to sign today, because this is connected to something that would be produced in Brazil, a very significant part of FCC eventually. It's a 5-kilometer transfer line with magnets that are extremely similar to Sirius magnets. So we have full capability of projecting and producing in Brazil. And we're talking about 10 times more magnets than we produced for Sirius. But I think that would be wonderful to engage a Brazilian company, for example, like WEG, and a project like Sirius that allowed us to have a significant participation. We're going to start with dipoles and eventually see if we move to other. We have to show that we actually have this capability to do this, but hopefully maybe we'll be engaged in many more parts of the transfer line. That's what I would like to tell you. Thank you.